Before we continue on and add in the more complex functionality into our Electric Dreams project, what we do want to do is to pull some of the stuff out of play game and put it into its own functions, because it's not really going to be part of the game. This is now the information about, as we look through here, this is really about setting up what we want to have happen when we have a generic response. So then if, when we're analyzing the answer from the player, if there is no identifiable answer, then we go through and we start using these kinds of things. So first, what we're going to look at is pulling the generic stuff into the generic section. So looking right here, this is going to really be our generic information as we're going to work with it. And we want to pull that out into a separate function. Just checking where my functions end at the moment. So I'm going to build a function called generic response, and it's going to do some of that. I'm also going to build a function that is going to be my end game. And end game is going to contain where we reassign this location, because we may end up making this a more complex ending where we provide some extra text, do some other things. So for now, I'm just going to leave it as that. So I'm going to put that information inside of here. So now we have endgame doing that, and replace that with a call to end game. So then we call the end game function. So we've now pulled it out and have separated it, because what I will want to do is to do a number of things. I want to change the message that the computer displays. I will want to remove the form input. I will want to actually set up a timer so that it makes it not go to this new location until so much time has elapsed, so that it allows the user to contemplate what has just happened to them when the computer stops allowing them to provide input, and then it goes off to its new location. So we're going to build some more complex items into that just to make it more interesting. But for now, we'll just call endgame and set up endgame to look like this. So generic response is where we find out, as long as there is a generic response to provide, we generate a random number. We don't need to log that out to the console anymore because we proved it worked. And then we're able to update our message here, and then we can remove that item from our listing. Now, there's something we're going to want to modify how we're updating the computer's text in a moment, and do it a little bit different. And this will allow us to have a little bit more control over how everything happens. But for now, I'm going to just take everything that is contained here and simply cut that out and paste that over into my generic response. So we're off to a good track, or good option at that point. So if we call generic response like this, so we're checking what is the human's message, and then if the message is tired, we provide this input. If it's sleepy, this input. Exhausted, this input. Otherwise, if it's not one of those three terms, we spit out a generic response. And then as long as there is a generic response, it's going to populate the computer's message field with that text, remove that response from the list of responses, and then once there's no longer any responses to choose from, then it calls endgame. So if I run my program right now, what we'll see is absolutely nothing has changed, but what we have done, we've started to break down the logic into making one function do one thing. Because under play game, what we're going to want to eventually do is we will want to analyze the input. And then we will want to update the text on screen. So these are the two things that we want to do. So what we're going to actually realize is this section here, which is analyzing the input, is one thing. And then here where we're setting the human value input back to nothing, we'll probably also at that point it would make sense to update the computer's HTML or its text. So that would be our updating our text on screen. So the concept is we're trying to separate it out into one chunk. So each function is just really doing one thing, or that function is just calling a series of functions. So play game is kind of a master function that's going to call a bunch of other functions. So it's like a controller, and then it's going to call these other functions in a stepped order. The thing that's useful when we start getting all kinds of curly braces and curly braces and curly braces, and you're left going, I don't know what lines up with what. When I'm inside of Atom, we'll see that if I click on a curly brace, it finds its mate, its pair. So if I click here, it shows that one joins with that one. Click here, that one with that one. What I also like to do is at the end of a thing, I will put end play game like this. So I know that that curly brace is the closing curly brace for end game right there. Now if I click here and see that how all that pairs up, I can see that as end if. So if you add in a comment at the end of your curly braces, it is going to help you when you're trying to line things up. So if I add in some more comments there and end game. So if we add in these different comments, it helps when we're looking at the code so we know what it belongs with when we are looking at these. So it also, if you add in that comment while you are doing it, what's useful about it is then when you start moving things around, you don't actually end up grabbing the wrong curly brace. So it helps you become more aware of which curly aligns with and is attached to whatever other curly brace. So I do recommend that as a technique. That will make things a little bit easier for you. So now under play game here, we really are going to be looking for two things. Analyzing the input, which is what is happening here. And the other thing I want to do is update my text on screen, which currently I'm updating the human's value by setting it equal to nothing or clearing whatever was typed in the field. What I want to do now is to pull a few things out as we work with this and create a couple extra variables that we will work with, because we're going to continue this process of having small chunks of code encapsulated within a function, so within its own set of curly braces. So instead of defining something like this, human message here, what I want to do is create a variable that I can access anywhere within my program. So I'm going to create a couple variables. I'll set one for my computer message, one for the human message, so that we're able to then work with these a little bit easier as we work through this. So I'm going to wander up in my code here where I have my things. So currently we have human refers to the text field that the human is inputting text in. Computer refers to the computer's paragraph right here that we put text on. What I want to do now is to create a variable I'll use let instead of const because this is a value that will change as we work our way through. And I will create a variable for a computer message. It's going to be a string, so I'm just going to say equal to an empty quote for now. And then let human message be equal to an empty string as well. So these are two values that we'll be able to work with as we go through the game. All right, so last week we referred to human message with message spelled out entirely. Now we don't need to use let anymore. We're going to, because we already defined the variable up top, so now we're going to, when we start out, we can say human message is equal to human value lowercase. Now what I want to do is to change where it says computer.innerHTML, and one thing I can do while I'm working in Atom, I can hold down the command key and select multiple items all at the same time. Hold down command and then just click drag, click drag, click drag. And now if I type in computer message like that, now these instances where it says human message, that all needs to be updated as well. So I should have done that all in one shot, but that's easy enough to redo. So now all we're doing is assigning new values to these strings. And the next thing is we will need to update the text on screen. So the first is we're analyzing the text and then figuring out what our response should be. Now we can update the text on screen. So, human's already been assigned. It's computer message computer dot inner. Now we're going back to the inner HTML is now equal to our computer message. So we figured out what the human message was, set it all to lowercase, analyzed it. Based on how we analyzed, we came up with a new message for the computer to say, and then we get to update the text on screen, which is changing the text on the computer and eliminating the text on the human. So rolling forward with this, we want to be able to keep track of our question track. Where are we? What question are we asking at that time? It's going to be a changing value, so it's not a const, but it would be we'll use let. And with this, I'm going to refer to it as question track. And in the beginning, I'm going to use our first question. We'll just call it start. That makes sense. I mean, first, start, something. This particular question, continuing with the examples I've written it prior, is usually a mood-based of how are you? So when we're asking that, we're looking for things like good and bad. Any more options will then send it into the generic responses with it. So the good part about question track is we're not setting up how many tracks we have at the beginning. We can just keep adding more as we expand and grow the project. So once we have a couple of different layers deep, it really is just rinse and repeat, just adding more and more in without having to go, okay, now I have to redo everything that I've done. So in a little while, everything that we need is going to be in place. We are just going to keep adding more to it, which is going to be super cool when that happens. So working with this first one, I'm not going to use what I had here before, because that doesn't go and lead us to further questions. All it did was just output some text to the computer. So I'm going to just comment that out. Eventually we can delete it if we want, or we can do something else with it. But for now, we'll just leave it commented out. So if we start out with an if statement, and if I can type, so if question track is equal to start this will be something. We'll go back to that in a moment. Else, what we want to do is call generic response. So if the question track is start, we do something otherwise we call generic response. So you'll notice that's similar to what we had here, which is we were already analyzing, and then if not, we called generic response. So because we're going to be analyzing a bunch of different things, what we'll find is we're probably going to be better off creating individual functions for each question track that we work with it, because it will keep it simpler and easier to follow. But right now I'm going to put the code here, and then we can always cut it from here, paste it into a function later, and roll with it. So we will leave it there. Actually, just in the interest of cleaning up the screen, I'm just going to delete that out of there for now. You can leave yours commented. I'm just trying to shrink it so I can see a little bit more code on screen at any one time. So what this first one will do is say if my human message dot index of, and the word I'll be looking for first is good, not equal to -1. So that means it did find it. So not equal to this, because if we take the index of good on that string, if it returns -1, that means it didn't find it. So if it's not equal to -1, it means it found it. We don't care where in the string it found it. We just care that it found the word good. Now, if someone had typed goodbye when we said, hi, how are you? And it would analyze and say, oh, yeah, I see the word good in there. So it's not smart enough to know that, well, if the answer is just a subset of a word, so we're not writing something that is doing that complex of string analysis. We're just doing real basic string analysis first, and that's why we're using index of. So now we'll set the computer message equal to glad to hear that. What is your favorite color? So every time the computer is going to respond with a statement, and then it's going to follow that up with a question. Now that question is going to prompt us with what the next question track is going to be. So if they said good, that we're asking a question about their color, that means our question track is going to switch to color, and then we will figure out how to assess their answers when they're answering things about colors. So if it's good, else if human message dot index of bad is not equal to -1, meaning we found bad. At that point, the computer message is going to be equal to you sound depressed. Do you like dogs? Now, when you're building your own project, you get to ask what questions you want. You figure out what question tracks you want. And you're able to then set up your project. So right now, the first question, the computer starts out and says, "Hi, how are you today?" And if we answer good or bad, it's going to provide a response. If we don't answer either one of those, then it's going to give us, actually, one second, I forgot one else right here. Else, so if we didn't see good or bad, then it's going to go with generic response. Now, if the question track is start, we're going to do this. Otherwise, we immediately drop into generic responses, meaning we've run out of question tracks to answer. So if we've gone through our whole flow chart of questions and question tracks and answer analysis, and we've reached a dead end, so we don't identify a question track where we've defined it out, then it will provide generic responses. And when I look at it, it comes up, "How are you today?" And if I were to say blah, we don't get to see the computer's answer. Like, what? Put in something else. So we're in the generic death spiral right now, and it's not working. And eventually a little bit more. Okay, now it goes to our GIF page, so something's not right. But if I say bad, hey, look, okay, that part worked. Now let me try again. Yes. Okay. We're having some problems here. So we got a few things to fix as we go through it. But that's a good place to be. First off, we'll notice that what we are doing now as we modified it is we set the computer message and then we set our question track. But then when I look at generic response sets the inner HTML equal to this, but then it says set it equal to computer message there. So what really should happen is this shouldn't be in generic response anymore. It should be computer message instead of being computer.innerHTML here. So it updates what that message is, but then we do our update on screen in one place. And this illustrates another reason why it's useful to separate functionality out with our functions so that one function is doing one thing. Because if I'm updating the inner HTML in two places, like I was before, notice how then my program broke when I didn't fix things. But if I only do one thing in one place, so I'm separating functions out so they just do one thing, it's much easier to now maintain our code as our program grows and expands in complexity. So now there's only one place where I'm updating the computer's inner HTML, and it's right here. And then I'm updating the human's inner HTML here by saying it's nothing. Now, I could even put that into its own function if I wanted. It is just 2 lines, so it's probably okay to leave it here. But from a strict standpoint, it would make sense to have it in its own function, and I was calling that. So it clearly illustrates what that is doing. So now generic responses only does one thing. It updates the computer message, or it goes to end game. So it just, based on random responses, it's doing one or the other. But it's not updating what that message should be and updating its HTML at the same time. So that's where that was causing an issue. So now it should work if I say something that it doesn't know. And now I can just keep going through. And it brought me out of there. So now if I say good, that worked. Now if I answer something, and again, now we're back in that same spiral. So now it's working. So sometimes it's fun when things, well, it's not really fun when things break, but it helped to serve a purpose when it didn't work right and be able to use that to learn from that. Now going back up into play game, we can see that, okay, I have all of this stuff tied to my start question. Now if I want to continue this a little bit, so if question track is start, let's try to find out color and dog as our next 2 question tracks. And if I do that with else if question track is equal to color, we can see that, all right, that's going to be okay. Now, if this whole if, else if, this is a whole lot of curly braces occurring in one place. The likelihood of making a mistake here is going to grow pretty quickly, knowing how hard it is to keep all of your curly braces balanced. To define out the color track, I'm going to just copy paste what I did with the start question track. So I'll just copy that. I'm going to paste that code in. But now the colors I'm looking for will be red and blue. Because now I could look for more colors, so I could extend this out if I wanted. I could look for red, blue, yellow, green, purple, pink, orange, whatever floats your boat. But I'm just going to keep it simple for now and just go with red and blue and fit that in. So red, you must have a temper. Do you want to fight? And my question track will then be fight. And then if they say blue, I will say, I thought you said you were feeling good. Are you sure you are not sad? And our question track there will be sad. As we're going to organize this so that it's cleaned up, right now it's starting to get convoluted because that's a whole lot of curly braces to keep track of, and I really don't like how that's looking. But if we look at the question tracks here, we realize that all of this we could wrap into a function. All of this I could wrap into a function. So these are things that I can now think about putting into their own functions. So I'm going to scroll down here a little bit. We'll leave generic response where it is, and I will say function. And what I want to do on this will be I'll call this start eval. And we'll put some stuff in it. And then I'm going to create another function, color eval. And what you will probably suspect is that as we start building this out, we're going to have a function for each one of these items. So if I go into the question track information there, I go grab that text. I'm going to cut that out of there, go back into color eval, paste that in. Now if I go into my start track, I'm going to cut that out of there, go into my start eval, paste that, and then if the question track is start, I want to call my start eval method. If the question track is color, I'll call my color eval method. And now when I'm looking at play game is suddenly a whole lot more palatable and easy to understand. So we're setting the player input to lowercase and assigning that to our human message variable. Then if our question track is start, we call the start eval method. If our question track is color, call the color eval method. Otherwise, we do generic response. Then we finish out play game by updating the computer's text on screen, followed by clearing out what the person has input into their text field. Looking at this, it becomes apparent that our next step is really going to be to start filling out these different functions for each question track as our project is going to grow and our computer becomes more complex. Before I'm going to add in my end start eval statement, and I'll add in an end color eval and add in a and if you add in these ends on your closing curlies, it is going to, I think, help you as you try to start lining things up to make sure that your braces are properly balanced. Different question tracks, it's really going to become a matter of if-else ifs as we work our way through this. And if we start growing this long enough, we may decide that we want to use switch statements instead of if-else if, which are the same kind of things, but it can be a little bit cleaner to read. But for now, we're going to stick with the if-else if and decide later if we just want to turn it to something else. So if I say good, switch my track to color. If I said bad, it's going to switch my track to dog. So I'm going to do that one next. So at that point, we can just go else if question track is equal to dog. And now at this point, this will be my dog eval. You will notice that it's starting to become somewhat repetitive here. So with that, we can probably start just copy pasting things and putting it in and working out all of our different words that fall into it. So our start eval, our color eval. Now if I want to add in my dog eval, so function dog eval, just go right down and say and dog eval. So I'll just put in that closing comment right away because that does help us to remember what we need to do. Now, knowing that what's happening within it is going to be similar, I'll paste in from a previous one and think about what words I'm asking for. So here it says, do you like dogs? So the common answers I'll be looking for will be yes and no. So I'll change that to yes and no. And if they say yes, say wonderful, give an exclamation point. And now, so I have a statement from the computer. I'll follow it up with a question. Do you have a dog? And my question track will be dog owner. And if they say no, I'll say too bad. And now this time with my question, I'll say, are you a cat person? Now, it's interesting, it's like, do you have a dog? But often, with dogs and cats, then people who have cats, we call them cat people. So it's interesting how people with their different pets, and we describe cat and dog ownership differently. And this will change our track to cat. So now our dog eval is complete, and we can think about looking for dog owner as a question track, cat as a question track, and start figuring out what we want to say with those statements as well. So as this works itself out, if we look at it from good brought us to color, and if we under color, then we have fight and sad. But if we say bad, then we go to dog. And then if we under dog, now if they say wonderful, then we find out more about them as a dog owner. And if they don't have a dog, then we find out, are they a cat person? And we can now continue our logic, building out our tree one step at a time until eventually we have hit the end of it. And if we provide for a question track that is not on this list, it's automatically going to just dump itself into the generic response. The good part about that is we don't have to worry about it. I haven't figured out what dog owner question track is and done a dog owner eval yet. So if that is the question track, that's not one of these three, so it will automatically just put into the generic response end of game cycle. And then looking back at generic response, it goes through and does this, and then eventually we'll call end game. But I think I'm going to modify end game a little bit so that it gives a little more feedback to the user. So I've gone through and added on to the question track if-else statement. So we have start, which leads to color and dog. Color leads to fight and sad. Dog leads to dog owner and cat. So I've added all of those in. Oh, and then this is, I got eval right there. So if the question track is cat, it goes to cat eval. And then I've stubbed out the remaining functions here. So now these functions just need to have their text put into them to finish figuring out what the logic is for our program. That we're going to look at as we pull this whole thing together is to add a little bit more into the generic response so that it doesn't just automatically, when it's done, go away and just call end game immediately. But what I want to do is to set it up so that we first have our final computer message. And we'll set that equal to I am done with you, puny human. And then I want to make my human, which is the text field that we're working with. And I will set the class name equal to oh, wait, do I not have that class here? We have to, let's see. Oh, I don't have what I'm looking for yet. What I want is a class name that just sets the display to none. So I'll make a class called display none, and it will just have display none. And what that does is that allows me to have a class that I can assign two elements and make them go away. Normally we use display none and display block as our two kind of come and go sort of things that we can play with. So now if I go back here, it sees that display none is a class. So we're going to set human, so that will make the text field itself disappear. We'll just see the computer message remaining. So we're left with a, oh no, what did I do wrong? And then finally, what we want to do, instead of calling endgame immediately, I want to give the person 2 seconds to think about their fate and what has just happened to them when the computer has mouthed off to them and left them with no recourse to respond. And we'll instead use a timer method built into JavaScript called setTimeout. And what that requires us to do is to specify the function we want to call and how long we want time to elapse before that function is called. So I say set timeout. So I'm essentially starting a stopwatch. That stopwatch will run for 2,000 milliseconds, which is 2 seconds. But 2,000 milliseconds sounds way more impressive. But that means it's going to run for 2 seconds. At the end of 2 seconds, it will then call endgame. Endgame then assigns us to our new location where we get to see our dog on the jet ski. So if I save this and run it, we can quickly drop into our spiral of random responses by not saying good or bad. I'll say meh, and then now it's responding and go, what? Yes. Great. Why? And now we have 2 seconds to read that, and it goes to our dog on the jet ski. So we can see that it's working. It's a little better of an ending than just simply calling end game on the final one, because it provides a little sense of closure, so that we have 2 seconds where the user can't respond anymore. They have to read the final message from the computer, and then something happens. Now, if you don't want to leave this, you want to go back and start the whole process over, then instead of calling under end game, going to the new location, you could instead work on resetting things. Reset the question track. Repopulate the random responses, the generic responses, with new values, and then start over and call play game. And then when that happens, then at that point, we get to begin the process all over and feel that we're caught into a time loop, or almost like a Groundhog Day experience.